Hello friends, welcome. In last video, we explained or we learned about the definition of hybridization. Hybridization means it is the process in which a mixing as well as a recasting, that is a reorientation of atomic orbitals of same atom having nearly the same energy to form new hybrid orbital of equal energy is called as a hybridization. Then, why the concept of hybridization is essential? Hybridization is essential to explain the valences of certain elements, to explain the shape as well as geometry and bond angle in a molecule. Today, we will discuss about the important steps involved in the process of hybridization. It is an important concept. With the help of these steps, we can define or we can explain the formation of any molecule with the help of these important steps involved in the process of hybridization. In the process of hybridization, the important steps. The first important step is a formation of excited states. A formation of excited state. The electronic configuration of element in a ground state as well as in excited states. Okay? If, for example, consider the formation of BeCl2 molecule, barium dichloride molecule. Barium having atomic number 4, its electronic configuration in a ground state can be written as beryllium having atomic number 4, electronic configuration like that, 1s2 and 2s2. This is outermost state called as a valence state, in which s orbital has 2 electrons and these 2 orbitals are with anti-parallel spin and in pair. Okay? Here, the number of unpaired electrons in valence state is equal to 0. But the requirement of bonding in BeCl2 molecule is equal to 2. That is a required covalent bond is equal to 2. Valence bond theory does not give any explanation about formation of such molecules. According to VBT, the valence is equal to number of unpaired electrons. Here, the valence is equal to 0 according to VBT, but in actual practice, in BeCl2 molecule, its valency or it can form 2 covalent bonds with 2 chlorine atoms. When a number of unpaired electrons is less than number of unpaired electron is less than number of required covalent bonds. Then excited state electronic configuration is essential. When excited state electronic configuration is essential, when the number of unpaired electrons is less than a required number of covalent bonds. Here required number of covalent bonds is 2 and number of unpaired electrons is equal to 0. In this case, excited state electronic configuration is necessary. In excited state, one of or more than one electrons from lower energy level is promoted into a vacuum orbitals with higher energy. What is happening during excitation? During excitation, one or more electrons which are paired from lower energy level to higher energy level which have vacant orbital. In beryllium, 2p orbital is a vacant, 2p0. And hence, in excited state, 1s2, then one electron from 2s orbital is promoted into empty or vacant 2px, 2py0 and 2pz. One of 2s electron from 2s orbital is promoted into 2px1. This is known as an excited state electronic configuration. That is, one 2s electron is promoted into vacant 2p orbitals. After excitation, the number of unpaired electron in beryllium becomes 2, which is equal to number of required covalent bond formed in BeCl2 Okay. With the help of another example, we can explain step number 1, that is a formation of excited state electronic configuration. Consider a formation of methane molecule CH4 molecule. A carbon is a central atom having atomic number 6. Its ground state electronic configuration can be written as 1s2, then 2s2, 2px1, 2py1 and 2pz2. Okay, carbon has 6 electrons, 2 plus 2 4 plus 1 5 plus 1 6. 2s2, 2px1, then 2py1 and 2pz is empty or blank. Calculate the number of unpaired electron in valence state. In valence state, the number of unpaired electron is equal to 2. While in methane molecule, carbon formed 4 covalent bonds with 4 different hydrogen atoms. That is, 2 is less than 4. Number of unpaired electron is less than number of requirement of bonding. Hence, here one of 2s electron is promoted into vacant 2pz0. During excitation, one of 2s electron, that is from lower energy level, is promoted into a vacant 2pz orbital having a slightly higher energy. Hence, a carbon in excited state is equal to 1s2, 2s1, 2px1, 2py1, 2pz1. 2px1, 2py1, 2pz1 and 2s1. Okay? Hence, valence set contain 1, 2, 3, 4 unpaired orbitals or unpaired. 4 unpaired orbitals. And hence, excited state electronic configuration is essential for some molecules, for some elements forming a molecules. When number of unpaired electrons is equal to number of requirement of molecule, then no excited state electronic configuration is essential. It is a first important step of hybridization. Okay. Second important steps of hybridization is a mixing and a recasting or atomic carbon. Here, depending upon a requirement, one or all orbitals in a valence state, one or all orbitals of valence state or same atom mixed together to form an equal number of new orbitals having nearly equivalent energy. Okay? What will be happen during mixing? Depending upon the requirement, one or all orbitals of valence shape are present in the same atom mixed together to form a new orbital. This new orbital is equal in number. They have equivalent energy, and this new orbital is called as a hybrid orbital. For example, during a formation of methane molecule, CH4 molecule, 2s and 2p orbitals. During formation of methane molecule, 2s, that is 2s1, 2p, 2px1, 2py1 and 2pz1. Atomic orbitals of same carbon atom mixed together and form 4sp3 hybrid orbitals of equivalent energy. Okay, this is a state number 2, a mixing depending upon requirement. Okay, such kind of mixing takes place. Then after this mixing, these hybridized orbital orient themselves in available space to minimize the repulsion of electron between them. That is to minimize repulsion and to achieve a stability. That is the next step is orientation of atomic orbitals. Step number 3, orientation of hybrid orbitals. Why this new hybrid orbital oriented? These hybrid orbitals are oriented in a space to minimize repulsion between electrons and to acquire a maximum stability, such kind of orientation or redistribution of atomic orbital takes place. Here, in methane molecule, these 4 sp3 hybrid orbitals are arranged towards the corners of a regular tetrahedron. To minimize repulsion, 4 hybrid orbitals are arranged toward the corners of a regular tetrahedron to minimize repulsion between them and to acquire a stable stability. Okay, they are acquired towards the corner of regular tetrahedron. If there are 3 hybrid orbitals, these 3 hybrid orbitals are arranged towards the corners of a regular triangle. 1, 2, 3 hybrid orbitals are arranged towards the corner of regular triangle. If there are only 2 hybrid orbitals, these hybrid orbitals are arranged linearly, having a bond angle 180 degree. Okay. What are the important steps? Important steps of hybridization is a formation of excited state. Why it is essential? If number of unstable electron is less, then required number of bond formation, excited state is essential. Then step number 2, mixing and recasting. Depending upon the requirement, a mixing of atomic orbital takes place. Then these atomic orbitals are oriented in available space to minimize a repulsion of electrons. Okay, these are the important steps of the process of hybridization. Characteristics of hybridization, that is, features or important points of hybridization. During hybridization, atomic orbitals of same atom undergo hybridization. That is, one orbital of one atom and second orbital from second atom. Such behavior will never happen. The atomic orbitals of same atom undergo hybridization. For example, during formation of methane molecule CH4 molecule, a 2s and 2p orbitals of same carbon atom, one carbon atom, undergo hybridization. That is, hybridization taking place on a same single atom, which is an important characteristics of hybridization. Then second important characteristic is hybridizing orbital have a nearly same energy. Okay. During formation of methane molecule, a 2s and 2p, 2s and 3 numbers of 2p, 2px1, 2py1 and 2pz1 orbitals undergo a mixing for 4 hybridized orbitals. These orbitals have a nearly, not exactly, but they have nearly same energy. That is, a 2s orbital and 3p orbitals cannot overlap with each other because the difference in energy between these 2 orbitals is maximum. They must have near same energy, which is a second important characteristic. Then another important property is only atomic orbitals and not electrons undergo hybridization. That is, during such kind of hybridization, only 2s orbital and not electron present in orbitals. Only atomic orbitals undergo hybridization, that is a mixing process. Then, fourth property, the number of hybrid orbitals formed is equal to the number of hybridizing orbitals. That is here 1 PS and 3 2p orbitals. Total number of 4 orbitals mixed together to form 4 number of hybridized orbitals. That is, the number of hybrid orbitals is always equal to the number of hybridizing orbitals. Okay? It will be never happen. That is, number of hybrid orbitals is equal to 4 and hybridizing orbital is equal to 5 or 3. They must have same number. जेवढे atomic orbital mix होतील तेवढेच आपल्याला hybrid orbital मिळतील. Then next feature, each hybrid orbital can contain or can have a maximum of 2 electrons. In these hybrid orbitals, they contain a maximum of only 2 electrons, not more than 2 electrons. That is, each hybrid orbital can have a maximum of 2 electrons. This hybrid orbital form has a 2 lobes. One lobe is a larger, while one lobe is a shorter. Out of these 2 lobes, suppose this is hybrid orbital. One lobe is a larger, while another lobe is a shorter. Next and last one, a covalent bond formed by this hybrid orbital, overlapping of hybrid orbital is stronger than the bond formed by a pure atomic orbital. That is, a covalent bond formed by hybrid orbital is stronger than covalent bond obtained by mixing of pure atomic orbital. Okay, these are important characteristics of hybridization. In this video, we discussed about the important steps of hybridization as well as important characteristics or properties of hybridization. Okay. Now we will stop here. Thank you.